Now this is the simplest practical we are having in communication. First is what your audio generator, what it will be generating.
Noise.
Modulating signal. काय रे तिसरं प्रॅक्टिकल आहे ना हे काय आहे? What is this? Getting pulse generator. So this is a
Carrier signal.
We call it as a pulses. Strain or pulses will be generated here. This is what your modulation. This is what your demodulation. Now what you have to understood here, at what frequency you are going to get the demodulated signal back. That is what your sampling theorem is. Okay. So first we will observe the, you can change the modulating signal frequency using this P1 and P2 knobs. Okay. What is the range of frequency amplitude here? 0 to 5 volt. And frequency range is from 300 Hz to 3.4 kHz. Okay. So let's observe here the modulating signal. Can you adjust? So this is what your modulating signal. Now amplitude and frequency of this you can change from this end. You can go to your lab menu where the steps all are given to you. So I am changing the amplitude and the frequency here. You can set. This is what you are modulating. Whatever the frequency you are noting down here, you have to write down the frequency, because finally you have to prove that at Fs is equal to 2 times Fm, you can accept the modulating signal here. So this is what your modulating signal. Let's measure it. What is the channel 1 frequency? 1.6 or 1.7 kilohertz. It is showing you somewhere. Okay. Now next is the train of pulses. So this is what the train of pulses. Again the amplitude and frequency you can change. What frequency we have kept here? 1.7. So it should have double frequency. So if it is less than 2 times 1.7, you won't get the perfect sampling. How you can identify whether it is perfectly sampled or not? If you are able to reconstruct your signal after demodulating, then you can say that the sampling theorem is okay. Otherwise not. Means the sampling frequency is exactly 2 times the FM. At that time you will be able to demodulate your signal, means extract the modulating signal back. Now this is what your what is the amplitude and frequency you can change. This is pulse width adjustment. What I have stated, if you are increasing the pulse width, what will happen? So you have to also observe the effect of increasing or decreasing the pulse width. See, I am increasing, so there is no pulse width. So this is what your ideal pulses that you have generated. If you are increasing the pulse width, see, this is what you are increasing the pulse width. So you have to also study what is the effect of increasing or decreasing the pulse width. You can measure the pulse width here by setting the cursors. So you can set the cursor here. So you can measure how much is the pulse width. What is the delta here? 80 microseconds. So you have set the pulse width as 80 microseconds. So you can increase or decrease the pulse width and see what is the effect of increase or decreasing the pulse width on your sample signal. Okay. Now we have set this. Now we want to see or observe what your modulated signal. Now in the modulated you can see here is a natural sampling. This is sample and hold. This is what your flat top sampling. So first we will observe what the natural sampling. So for that you have to connect the modulating signal here. This is what your modulating signal that you are connecting at the input of your modulator. And second is what you are getting pulses that you will be connecting as input. Not needed, I think they are by default connected. Okay. So let us observe whether you are getting the natural sampling. Proceed. The dotted lines are showing. Let's see whether it will need to connect. Now you can observe this is the this is the sample version. It is a natural sampling you are observing. Now what you have to do here, you can change the parameters. Okay? So you can observe by changing the pulse width. See what is different from this. Increasing the pulse width. This is your ideal sampling case. If we are increasing the pulse width, this is the maximum. So you are having only one pulse in one modulating signal. This is what your natural sampling case. Now next is, let us observe. This is which type of sampling? It is your flat top sampling. So all the tops of the samples are flat. So after that it is vanishing when all the tops are. So this is flat top sampling. And sample and hold circuit, basically you can measure the time of this. And this is exactly what the output of your flat top sampling you are getting. So both are almost the same, which is showing you the. So you can see. So all the tops of the samples are flat here. Now with the natural sampling itself, you have to see whether you can reconstruct the signal back or not. So this is what your natural sampling. Now output of this will be connected as input to the modulator. So this is what the modulating signal. So from here it is connected. What you should get here, modulating signal back. If you are not getting, then you have to adjust the sampling frequency. So you are getting the modulating signal back which you are transferred. Now what you have to observe, if you are changing the sampling frequency, is there any effect on this? See, if you are increasing, it will be distorted. If you are decreasing it, so you should have your sampling frequency exactly 2 times that of your FM. Then only you will get the demodulated signal. So if I am increasing this, distorted, now it is getting exactly. So with the frequency you can measure. It must be 2 times whatever we have said. It was something 1.7 something, so it will be double than that of, then you are going to get the original signal back, that is modulated. So this is how you are verifying your sampling here. Clear? If you want to observe the spectrum of the sampling, again what you have to do, observe the FFT of that. Increase or decrease the sampling rate and observe whether you are getting overlapping of the signal or not. Let's say this is natural sampling case that we will be studying.
निकल एकदम. हाँ मेरा हाथ फ्री है.
दूसरा चालू करो वीडियो, इसमें कंटिन्यू करो.
Now we want to observe this. It will be area of the sample from PCEL. These two times FS only you are going to get, otherwise not. So now with this, now going the mass menu, observe the effective set of the variables. So now this is what you are going to get the, all the frequency components in your modulated signal. Now you are not going to get FC and vector. What we are going to change here, the frequency. See what is the effect here. And decrease the frequency, so what is going to happen, all the bands are coming very close to each other. So that will be causing what, your aliasing effect, overlapping. If I am increasing it, see, these are all separated now. So this is how here frequency is affecting the frequency spectrum. Still you can zoom exact. Now at this time you are getting the exact frequency components here. Let's see if we can zoom it. Let's see, observe it. See, I am increasing, this is decrease. So I am increasing. So you will be able to see it exactly all the bands separated where the frequency is exact.